In question 13, you're looking at how the height of a ball above the ground changes over time. Now, when we look at the rate of height change here, it will be the derivative, or negative 10t plus 40. Now, what rate of change are we looking at? And that is when t is equal to 2, that will equal negative 10 times 2 plus 40, which is going to be 20 meters per second. For B, velocity when t is equal to the rate of change of height, when t is equal to 3 seconds, that's going to be 40, take 10 times 3, or 10 meters per second. For C, at what time is the velocity negative 10 meters per second? That means it's heading down. By definition, we use negative for a downwards velocity. So we'll determine that when that occurs. So time in this instance is going to be 5 seconds. When was the velocity 0? That will be at the top of the flight, or when the rate of change of height is equal to 0. T is going to equal 4 seconds. The height at which that occurs, we'll have to do a little bit of substitution. And that will work out being 80 meters. To work the time out where it hits the ground, well, what we've got to look at there is when the ground height is 0. So if I solve that, we can say therefore minus 5t squared plus 40t is equal to 0. So therefore t is equal to 0, which won't apply because it's when the ball was released, and t is equal to 8 seconds. To work the velocity there, dh on dt is going to equal 40 minus 10 times 8 minus 40 meters per second. And if we're talking about speed, that'll be 40 meters per second.